Next curve.
Hey everyone, this is Leonard Lee, Executive Analyst at NextCurve. Welcome to NextCurve's Rethink webcast, where we provide you with the tech and industry insights that matter. And today, I'm joined by Ian Cutress of More Than More. So the last more is with two O's, right? And I suppose you're going to explain that later to us, Ian?
Yeah, sure. Thanks for having us on, Leonard.
Yeah, no, it's great to have you. And, you're going to be, it's great to have you, number one. And I want to have you on, hopefully on a pretty regular basis here for a thing that I'm calling the young guns of semiconductors, research, okay? We intended to have Dylan Patel, who is the chief analyst at Analysis, joining us, but he came down with a bug, so he wasn't able to join us. But the reason for this is because I consider you and Dylan sort of the young guns of the analyst world covering semiconductor industry, and I think it would be great to get your take, Dylan's take on a regular basis, so that us old guys, us crusty old guys, get a flavor for what the young guys are thinking and saying and seeing.
I'm 10 years older than Dylan, so Dylan's not here because his immune system hasn't grown yet to take over the bugs that we get from conferences. So maybe there's a downside to being young in this game. Yeah. You need to have a sufficient immune system.
Yeah, it takes something like a COVID to bring me down. So, I'm pretty rugged. But
fingers crossed, haven't had it yet.
Wow, are you serious? Congratulations.
Serious.
Yeah, I mean, I think that's statistically impossible, but congratulations. But hey, Ian, for the audience, folks in my audience who don't know you, why don't you introduce yourself really quickly and the work that you do?
Yeah, so my background's a bit varied. I came out of a material science PhD and became a tech journalist for the best part of 11, 12 years, writing for a online publication called Tech. My focus there, spent a few years focusing on motherboard design, and then pivoted to CPUs and semiconductors, and now this world of AI acceleration. I left that a couple of years ago and became a full-time analyst, helping companies with especially technical messaging, making sure that they're telling the right stories out in the market and making sure they're getting the details correct, preparing them for the questions that I would have asked them in the press briefings. Also, for the last 3, almost 4 years now, I've been running a YouTube channel called Tech Potato. Yeah. So the joke is it's twice the tech and some chips, where I spend most of my time speaking about the latest and greatest in silicon in the industry. I attend a lot of research conferences to find out what's new in semiconductors, what's going to be the hot stuff. So, for example, when we saw things like buried power rail at an event 5 years before it came into fruition, we're seeing now 1 kilowatt, 2 kilowatt, the research being done on how do we cool those processors for when they come down the pipe. Yeah. And recently I've been producing a show called the AI Hardware Show, which I co-host with Sally Wood-Foxton from EU Times.
Oh, really?
Where we look at the AI hardware in the market, the startups, how much funding they've got, how much traction they're getting, and eternally answering the question, who's going to dethrone NVIDIA?
Wow, where do you find the time to do all this stuff? It's amazing.
I don't. Before we went on this call, I was editing the last episode while also making sure we get a sponsor for the next one, and it all goes through and through.
Generative AI, please.
So the fun thing is, as an influencer with a social media person with a YouTube channel, I do videos about AI all the time, and I recently did a video for a client. I quoted them a 10-minute video, and it came into about 8.5 minutes, so I thought I have to add something. Right. But I was on an aeroplane. You can't exactly record something on an aeroplane that's going to work. So I went to a tool that I use. I wrote a script. I then put it through a text-to-speech machine learning algorithm that was fine-tuned on my audio from that episode.
Oh, okay.
And I inserted a 40-second bit of audio that was AI generated with some B-roll into that video. Nobody suspected a thing.
Wow.
Even fooled my wife.
Wow. Incredible. That's really cool. So, hey, I wanted to pick your brain. Where you think we're going in 2024? I mean, you mentioned AI. Obviously, AI computing is like the topic du jour in the industry. Everyone's anchoring their hopes on this just going, uber hockey stick, so that some analysts, research firms can brag that we reached a $1 trillion mark before 2023. But what excites you? What do you think is going to be like the big thing in semiconductor tech and industry trends?
So as you say, the trend we're seeing is machine learning. Generative AI was 2023 through and through, the rise of ChatGPT, Stable Diffusion, and a lot of these companies coming through, and everybody buying up as many GPUs as they can. We've literally just had Meta, Mark Zuckerberg, saying they're going to buy another 350,000 GPUs this year, which is insane if you consider they're 30, 40, 50 grand a pop as well.
Yeah.
A video I did recently, I think, is actually quite poignant for as we look to 2024. It's what do we do beyond large language models? Yeah. The talk of 2023 was always about ChatGPT. How do we integrate this into services that businesses can sell and make money from, or at least benefit? And one of the big ways I've seen the benefits of those language models is in HR. The ability to streamline the HR processes, whether you're hiring and you need to find the right words to promote for the job that you're putting out there, or helping autofill people who have gone halfway through the process and maybe you're able to find exactly who they are through their online presence, integrating both regular stochastic but also machine learning tools together. And I've seen quite some companies, saving 50 to 70% of their HR budget in a quarter by implementing a strong, cohesive, large language model experience. But unfortunately, there is a bit of a hype bubble around it. Everybody's thinking, how many parameters, and we're hearing things like Llama 2 and Claude and developing for anything from smartphone to the data center. And the question is always, what's the business model to generate revenue? Is it how many tokens you produce? Is it the output, or is it just the savings in productivity that you create from deploying it? The question needs to be asked, what's beyond large language models? Because machine learning is such a broad topic. Everybody thinks...
Yeah, but do you mean technologically, or do you mean in terms of what is beyond the large language model and the investments in the chips, the systems, the infrastructure doing X, Y, Z? I mean, what do you mean by that?
So look, business use cases, and I think this works better through examples. So take medical data, the ability to use generative AI to predict new cures for diseases. And what you do is you need large amounts of current medical data, interactions between chemicals, to feed into machine learning models to potentially get a result. That's nothing to do with language, but it's something that could, as a service in the medical industry, be really, really important and potentially be worth billions, if not trillions. Geospatial data, the ability to predict microclimate and weather. Weather modeling's been a massive thing for decades, but suddenly we have tools that could help accelerate, reduce the search space in some of those algorithms. Being able to automation modeling for factory work. I mean, we kind of have this already, and NVIDIA has these twins where you can model your factory and find out inefficiencies and do improvements there. Well, what about generalized models that can do that end up being fine-tuned for the workplace that you're involved in? Or analytics that are coming out of autonomous driving.
Sure.
The ability to predict hardware failures at scale, whether you're running an AMD chip in a Tesla or an Intel chip in a BMW or a different chip in a Chinese vehicle, models around there and developing where the business use cases are around that. It's kind of what I call the beyond large language model era. Because we're so caught up in large language models, and obviously there's got to be silicon to support that and new features. For me, it's always about everybody talks about the killer use case whenever new hardware is developed, whenever new software is developed.
Yeah.
My question is, what's beyond language? Language is easy because language is plentiful and bountiful. We're going down that way with images, with Stable Diffusion.
Yeah.
But again, what's beyond? What's the next business use case? And all the investors that I speak to are all asking how much of this is a fad versus how much of this is real versus what's the next thing I should be jumping on today before everybody else does.
But don't you find, okay, so, I talk about this stuff with investors, big players in the semiconductor industry, just like you, as well as their customers. And one of the things that is very apparent to me is that a lot of the value propositions are around generative AI, large language models, tend to be hypothetical. And then also, if you examine what the assumptions are around how value can be channeled through the use of a large language model or a direct use or application of a large language model, the assumption is that there is some sort of high reliability deterministic outcome that comes out of these things. Are you hearing some of the same things? Or as you're going to and looking at what's beyond the large language model, are you asking those questions as well? What are you seeing in terms of the level of awareness that these are probabilistic systems? They're tough to implement. We've been using ML, AI in general for a long time, but they're still really tough to implement in a way that is highly valuable, right? So, what's your take?
Yeah, what we're seeing actually, because language is a good example, is this sort of intermediate layer of companies coming out doing fine tuning as a service.
Sure.
So there's a few companies doing the large foundation models,
right?
And then Lam and I currently work with AMD hardware to do fine tuned language models, and then they get deployed by companies who want to use them. And the stereotypical example is like, help bots and chat bots.
Right.
One of the issues that I think a lot of us face in this new technology is that we think about it from a consumer point of view and not necessarily from a business point of view. So everybody's thinking, how can it help the user? In the HR example I gave, not the amount of people I've told that story to went, oh, I didn't realize you could use it there. Because it's not a consumer-focused use case.
Sure. Yeah.
But then if we take it to the semiconductor industry, then we start talking about, say, chip design, and the ability to use machine learning to optimize chip design. Again, it's not a business use case. It's not a consumer use case, so not a lot of people are thinking about it.
Sure.
Yeah, I think you're right. The question is always, where is the value and how much the value is real versus a hypothetical might be there in the future. What we're dealing with right now is everybody's got a pickaxe. Everybody's got a variant of a pickaxe because everybody's optimizing their pickaxe. The question is, where do we go mine? Yeah. Where do we...
Not a gold. Or maybe even platinum.
Yeah. So where is the rare earth metals that we need to find with these tools? And ultimately, the ones selling the pickaxes usually make the most money.
Yeah.
So NVIDIA.
Yeah. Well, yeah. And like I said, these are like platinum pickaxes. And the question is are you mining for, at the end of the day, fool's gold or gold? And even if it's just, I mean, you got to find something more valuable than platinum. You know what I'm saying? But anyways, that's my. I'm going to throw that out there.
Minecraft analogy. Yeah. Yeah.
Okay, so let's get back into the nerdy realm that you usually dwell in, which is the deep semiconductor industry. And technologically, I mean, what do you see coming out of 2023 that you feel is going to have some significant impact in moving the ball? Because it's not just about the power efficiency of AI
Hmm.
compute. There's this whole I guess, like this backdrop of sustainability that we're all thinking about and talking about and starting to talk about. I mean, I don't think we really talked about in 2023 because I don't think people realized how power hungry these
Mm.
AI computing infrastructures are, right? So, I mean, what are your thoughts?
To be honest, the ESG, environment, sustainability, governance, that kind of goes out the window when the demand for power trumps everything. And right now, what we're seeing is a lot of companies, the demand for, they're willing to pay to get the hardware and they're willing to pay to run it, regardless of how efficient it is. Because they want the end result, because that's where the value is, and that justifies the end cost. As things may start to slow down, though they have no signs, NVIDIA has a 52-week lead time right now if you want a GPU, and AMD might be going the same way. So in terms of efficiency, it's in terms of AI hardware, it's more about how much compute can you get into a data center. Because right now we're actually dealing with data centers with fixed power budgets that are already full. So how do you get more performance out of a data center that's full? Well, you need more efficient hardware.
Right.
And that's why there's a drive. We saw AMD launch their new MI300 series at the end of last year. And to be honest, I think that was one of the highlights in terms of when we look at semiconductor design. They're doing a mixture of 2.5D and 3D heterogeneous integration. We've got high performance HBM and lots of compute and a disaggregated design in a GPU, which we've never really seen before. Intel's Ponte Vecchio notwithstanding.
Right.
And one of the key drivers over the future is how many chips are we putting together, the costs to build those chips, because obviously chip manufacturing increasing is going up, and that's also being pushed by AI hardware bit wanting to be developed. Nvidia's putting as many orders in. There's a limitation on the packaging that's driving everybody's cost up as well. So this move to this chiplet disaggregated architecture, it's a difficult nut to crack beyond CPUs, but we're getting there. And I think as we see MI300 proliferate through the ecosystem through 24, there's talk of NVIDIA's next generation design using chiplets. We don't know whether that's compute, memory, or something a bit more esoteric. We're going to see that coming to the fore. And on top of that, there's new process node technologies. So we've just seen TSMC's 3nm launch with Apple's smartphone silicon. Other companies are going to be coming out with their equivalents, but it's the next generation beyond that when we're fundamentally changing the design of the transistor. We're fundamentally changing the design of the power delivery as well for chips. A lot of people will be expecting, significant uplifts in performance and efficiency. And I think we've got to meet expectations that in some aspects it may be performance, in some aspects it may be efficiency. One of the things I've noticed with the semiconductor industry as a whole, if we look back across the last 30, 40 years, it's always been performance, efficiency, and then they scale out the most efficient part. Performance, and then efficiency. And every time we scale up in performance, we're always pulling in a new dimension, whether that's die size, whether that's power, whether that's frequency, whether that's core count. And now we're moving into chiplets, and ultimately, what's the fundamental limit of power of one of these chips? We're going to density, and then we come back to how much power do we have in a data center limitation, as always.
Right, but then there's also an economic element to all of this, right? Because 3nm and beyond. I mean, people argue 7nm and beyond. It's getting increasingly. I mean, we want to talk about a hockey stick. There's a hockey stick for you, right? And so scaling is becoming a costly thing for the fabs, and for chip designers, the design costs are going through the roof, right? So that's another element as well. Now
it is, and if we
feel that it doesn't factor in as much as all the other things.
It's as long as there's high demand for compute, it doesn't factor in as much, I think. But what we're simply seeing is a stretch out. There'll still be companies staying on the leading edge, and there'll be companies that will be N-1, N-2, and they'll just go up with everybody else, and then maybe they'll fall back another depending on volumes and depending on what's available. If you look at the research, there's a research path out to 2036 in terms of transistor technology.
Yeah.
And there's 10,000, 100,000 people working on that. The question is, what can you design today that will be effective when it's launched? So stuff you're designing today in 24 probably won't see the light of day until end of 27 at the earliest.
Right.
One of the benefits of moving to this chiplet disaggregated system is the fact that only a specific part of your product needs to be on the leading edge. So that's the bit that's going to be the most expensive.
Right.
But because it's a smaller chiplet, you might, instead of making 50 in a wafer, you're making 1,000.
Yeah.
So actually fewer wafers go further.
Right.
So that kind of amortizes a lot of the cost that's going in. Right. If you actually see some of the breakdowns of how much designing a chip costs on a modern process, it's getting to the point where half of that is software. Mm-hmm. Licenses to Cadence, Synopsys, and Synopsys just acquired Ansys, announced that they're going to acquire Ansys. So there are fewer players in the game. So the software is getting more complex because we're dealing with chiplets that have thermal interactions along with electrical interactions. We're doing die stacking. That's just more complex in terms of the calculations you have to make, and you need the software to be able to do that. That being said, we have had a bunch of AI startups, over 100 in the last 5 years, come together and build chips for less than 10 million. VC funding, multiple generations, still using Global Foundries 12 or TSMC 7 or TSMC 16 or what have you. And it turns out you can do pretty good work with that. That's targeting some of the market or doing innovative work like Cerebrus with their wave scale engine. And a lot of the embedded stuff maybe is using 16 or 28 nanometer. So there's still a high desire to build chips in a market that's growing and a market that just seems to want everything right now. So leading edge is always going to be a unique use case. And it's going to rely on the $1 trillion companies to drive that. Right. So that's the Apple, that's the Nvidia, they'll get there. But then you also, but no, yeah. So everybody else is going to be using chiplets around the same size as Apple, right? When they first used 3 nanometer. But now we've got the cloud companies are designing their own chips in 7 and 5 nanometer. Yeah. The automotive companies that have hired tech CEOs, right, because they need to be involved in the supply chain. It's I was speaking to somebody the other day talking about how companies now want to take control of their own chip design. So they're actually building chip teams. And I've just seen Sam Altman of OpenAI saying he wants to build his own fab.
Yeah.
So
you know what? Let's save that for a different episode. Because I really scratch my head about a lot of that stuff. But we'll jump on with Dylan and we'll chat about that. That'll be one to pursue with him. But I wanted to talk to you about really quickly about AI PC, simply because you and I seem to show up at a lot of the big AI PC events. And, what's your take? I mean, we've been hearing about AI PC for the better part of, I would say, 12 months, right? Since people started going bonkers about it. Ever since Intel hinted the fact that they will be putting in some AI acceleration. I mean, Apple's had some AI acceleration in their chip for several generations now. Qualcomm
they've had the Hexagon DSP, and that's now coming, with Orion into laptops in a big way.
Sure.
AMD with the Xilinx acquisition now has Xilinx AI engine IP.
Mhm.
So it's getting to a point where suddenly we have this new accelerator, and all the companies involved in building and selling the accelerators are excited.
Right.
Customers don't seem to care.
Yeah.
Which is, and I think there's what we're seeing is a cycle go round, the same we did with GPUs. When GPUs first came out to the fray, and NVIDIA will say they coined the term, there were a dozen plus players,
Sure.
each trying to use different interfaces, different APIs, whether it was DirectX or whether that was OpenGL or something proprietary. And then you had game developers and visual effects people all using a variety of different tools. And eventually we saw consolidation on what was around the thing that worked. But it had the killer use case of graphics and graphic design. The AI PC is in a similar state to where GPUs were. We've got 4 or 5 different AI accelerators, all of them using different APIs, even though some of them could technically use something in common. They don't, because they want optimized solutions.
Yeah.
But we still don't have a killer use case for AI PC yet. And what we're seeing is companies like Intel, Qualcomm, like AMD, showing little bits here and there, but ultimately in those markets you have to think, what drives sales? And ultimately it's experiences. Experience with a CPU is easy. Does it feel fast? Experience with an SSD is easy. Does it slow down? No. Good. GPU is also a fairly easy sale, because does it game well? Can you decode video? Can you encode it? Yeah. With the NPUs, with this AI PC concept, we don't have that. I mean, we have Windows experience features that do the deblurring and the eye gaze tracking. It does that, but once you hit a minimum level of performance, it's supported.
Sure.
And that's
a good point.
Even if you go towards some of the generative AI demos that we've seen, things with image, things with audio, again, are they going to be integrated into the operating system? Is everybody going to be able to use it? How do we use it? Will a user ever be able to distinguish whether it's on the NPU or the GPU, and does that matter? So what we're seeing right now, this year is going to be the year of the AI PC hardware. The question is it going to be the year of the AI PC use case?
Right. Yeah, it oddly sounds very similar to 5G, where everyone got excited about it, had a lot of hypothetical use cases that they thought were going to foster trillions of dollars of economic value, and then we're halfway into it, and folks are still scratching their heads. Right, monetization continues to be a challenge. And so, I mean, I tend to agree with your assessment. I think when it comes to what are those valuable applications that are going to be able to foster a return for everyone who's investing billions, if not $1 trillion. So, IDC might actually get their forecast right here. Where's the payback? Right.
It's tough.
It has to be really friggin' big.
Well, you bring up 5G, and that's an excellent case, because what you have to compare is, are we simply accelerating what we can do today, or are we providing something new? Right. People pay for new. People rarely pay for faster today, right? Unless they have a business use case. And the thing is, with 5G, we did exactly the same thing we were doing with 4G. And we're doing it faster. You can have more people in a room, and there's more flexibility. But ultimately, we were doing the same thing.
Sure, right.
So who's paying extra for just doing the same? And I think AI PC is going to be in that realm. It does have the advantage that we're still learning what machine learning is good for.
Sure.
On the PC, so there will be some new use cases that could have been done on the GPU before rather than the NPU. But ultimately, it sounds like it's going to just be, here's a thing that makes certain things on your system faster or lower power. You won't really know it's being used.
Right.
And that's the experience we're trying to sell you as something you should pay extra for.
Right.
The problem is, so Intel says 100 million AI PCs by the end of this year. Technically, anything with a CPU is an AI PC. So we could go back 20 years, and everything's an AI PC, right?
Right.
We're not doing new compute. We just have the power to do it for the first time. That's all the AI PC is.
Right, and more power efficiently for some select workloads. And does that make a difference? I mean, quite honestly, the only use cases that I see where this could be just really cool and potentially enhancing in terms of a monetization perspective is NPC, non-player characters, in whatever ways they can be applied, whether it's in gaming, the adult industry. And people don't talk about the adult industry. I think it could be phenomenal there.
So there is a problem there. There is a problem because you mentioned the NPC stuff, and I'm sure you saw the demo NVIDIA did at CES that I did, where you could interact with NPCs. The problem is half of that was done in the cloud, not on device, because they required large language models that need 50, 60, 70 gigabytes of memory. And a modern AI PC, I think Microsoft actually just put out some minimum specifications for this year of only having 16 gigabytes. And that's not enough. So some research needs to be done in how do we get the same level of accuracy and integration in a much lower memory footprint. And research has been on that for the last 5-10 years.
Right. So like a lot of this talk around hybrid AI architectures, right? And so I'm not suggesting that I'm talking in general an application, right? How that gets implemented is going to be a mystery. And for a lot of other, in my examination of all this stuff in the last 2 years, it's all still a mystery. We all have to still figure out. I think it's going to be a really fascinating area of research, innovation, and development. But yeah, and I'm sure you're going to be tracking it, and I'll be tracking it, and hopefully we'll have more fun conversations about this. But any last words on AI PC before we shut this down? This first episode of Young Guns of Silicon.
It's for AI PC, I think it's going to be a case of experience. For not only for consumers, but for us, right? Having hands-on with the hardware, using it day to day, finding out where we're using it. I'm a content creator. That's part of my job. So I'm already using some of these generative AI tools, whether they're local or online. So theoretically, I'm using an AI PC already. But as we move to this new hardware from Intel, from AMD, from Apple, from Qualcomm, and perhaps a few others later down the line, how many of those experiences move to on-device? We didn't touch on the security aspect as well of it being on-device. That's something that's worthy of a full conversation in of itself. But yeah, I finally have a Meteor Lake laptop. I want to be able to get one of the AMD ones in, and just I want to see if I can tell when I'm using machine learning on the device, and see how that evolves. I think that's going to pave how I perceive how this market is progressing forward for the next 12 months.
Well, those are great insights and great sharing, Ian. Thank you so much. I really appreciate it. And why don't you take a moment to tell the entire universe here how to get in touch with you, track your research, and, check out Tech Potato. Is it potato or potato?
Potato.
Potato? Okay.
Potato.
I just want to make sure I pronounce that correctly. Okay, potato.
Right. So iancutress.com has all my links. My main output is the YouTube channel called Tech Potato. I also have a newsletter called More Than More. You'll find it at more-more.com. The second more has 2 O's. On top of that, I'm highly active on Twitter and post anything between insights, memes, and everything in between.
Yeah.
And you'll also find me on LinkedIn. I've actually spent most of today going through TSMC's financials. Ooh, there's some interesting numbers in there.
Seriously, very, very interesting. Maybe we should talk about that sometime. But yeah, and don't forget, you do a lot of opining about like the quality of services that you encounter when you travel. I've seen you quite opinionated about that.
Right.
Anyways,
Yes.
wonderful to have you for the first time here on the Young Guns of Silicon. I like that. I'm trying to figure out if you're Emilio Estevez or what's his name? Oh, geez, Charlie Sheen.
Right.
Dylan's one and you're the other, but we'll make that determination when Dylan gets online with us. But thanks for tuning in, everyone. Remember to subscribe to the Next Curve YouTube channel and subscribe to the Next Curve research portal and media center at www.next-curve.com for a constant diet of the tech and industry insights that matter. And we will see you next time. Cheers, Ian.
Peace out.